I will be talking about how to make secure software. Obviously, that's a very broad topic, but we'll focus on some interesting stories. And I really hope that you don't learn anything new today, because that would mean that your software is mostly secure. But let's see that. A few words about me. As the presenter said, I'm a senior software engineer and architect, currently founder and CEO of LogSentinel. We do cybersecurity stuff, secure audit trail, and encrypted database. I will mention it a little bit through the talk, but not too much. I used to be advisor to the Deputy Prime Minister of Bulgaria for e-government and IT. I have a technical blog, used to be top 30 Stack Overflow user, haven't been answering in a while, so now I dropped to top 50, and you can follow me on Twitter. Now, what is information security and what is cybersecurity? Obviously, we won't delve too much into the definitions because that's some boring Venn diagrams. The point being that all of these circles, it is your responsibility. You have to handle everything, no matter whether it's information security, cybersecurity, ICT security, data security, or just security. And let's see where things can go wrong, because that's what security is about. It should prevent things from going wrong. Well, practically everywhere. They can go wrong on the front end, they can go wrong on the back end, they can go wrong in the infrastructure, and most importantly, they can go wrong with the humans that manage all of that. What would be the purpose of attacks to systems? Which is basically why we have to secure them, because some people might want to attack them. The most famous, at the moment at least, are the data breaches. It is breaching payment information, like credit card numbers, breaching just personal information for whatever reason, including emails, including behavioral data, like where you want to spend your money, how do you consume online. They can breach personal messages, emails, for political reasons. Other purpose of attacks is disruption of services. This means damaging reputation. For example, a few years ago, when we had a referendum on whether to have electronic voting, there was a DDoS attack on some of the institutions. It didn't stop any actual election process, but it did damage somehow the reputation of, well, look, they cannot handle a simple DDoS, how would they do e-voting? They might be trying to stop some time-sensitive services like promotional sales or, again, elections, which have to be up at the given moment if they're online. And there are the types of attacks where some men just want to watch the world burn. So no actual motive, just want to try it and see whether you can make it crash. And there are obviously all sorts of other motives, like trying to get money from the bank. That's a good motive. Extortion, personal vendettas, and state-level espionage, which is a very interesting, even for movies. I'll structure the talk by going through a little bit of front-end vulnerabilities, back-end vulnerabilities, and the rest. Obviously, won't cover everything, but let's focus on a few of them. First, XSS, cross-site scripting. This is something very standard, typical, and yet too popular, unfortunately. It means if you have such a vulnerability, it allows attackers to insert any JavaScript that would run on people's computers. And here you can see how it might look like if you didn't escape your input and output. Instead of displaying a comment on, for example, your blog, an attacker types in a crafted message, which includes some script, and then it outputs to all of the others who read that comment, and then the script is executed in their browser, which could do a lot of things, and they could be harmful. The prevention is to escape the output. Now, this is the mandatory thing to do. You can filter the input, but the most important thing is to filter the output, because even if you filter the input, someone can then change the contents in the database, and if you don't filter the output, it would still be an XSS exploit. You can have man-in-the-middle attacks, which is someone manipulating the data between your server and the user, and that might mean they can do anything with your users. And this might happen not simply by your connection to your server, but also to third-party resources, as we'll see in the next slide. And the other one is the cross-site request forgery, where an attacker can make your users submit things that they don't want to. For example, make a bank transfer. And this, it kind of allows them to execute forms with it's a JavaScript exploit. And the way to prevent it is to have one-time tokens so that each form submission is actually tracked against a server token. And if it has been already submitted, or if the attacker doesn't have the token, then they cannot do it. Now, some recent examples. British Airways recently allegedly leaked some millions of payment information from their reservation, I think, mobile application. Well, it was because of a static resource from their unprotected server, where the modernizer JS was modified by the attacker. And so whenever it was loaded on the page, the modernizer just got all of the payment details, the credit card number and the CVC number, and sent it to a third party. And yeah, they stopped it after a while, but it managed to collect a lot of payment information. How to prevent it? Limit third-party sources, check them regularly whether their checksums match, and do have some good operational security to prevent people modifying your JavaScript files in the first place. The other example is the New South Wales e-voting. This is a state in Australia, and they did this. They do e-voting, which is nice. And it was a very nicely designed system, all of the proper cryptography, the security of the vote, the privacy of the vote, everything was okay. But they used to have a PWIC analytics JavaScript included from an external source. And unfortunately, that external source was vulnerable to a downgrade attack on TOS. So an attacker could downgrade that particular resource, do a man in the middle there, so basically excluding the HTTPS at all, and then drawing anything on the e-voting site that they want. So they could practically change the order of the ballot, and you may think you have voted for someone, but to vote for somebody else, because of an external script loaded from a location that is vulnerable to a downgrade attack. Now, obviously, the prevention is to limit these third-party resources and to check for downgrade attacks. Another very simple front-end example, this is a very recent one from an Android app that simply exposed an unauthenticated HTTP interface to everyone on the mobile phone who wanted that. So any other app could just abuse and read your file system, even if it didn't have permissions to. A big list of best practices, obviously no time to go through them. There were talks on that previously. Go check the OWASP checklist. It was mentioned today, I think, a couple of times. Focus on access protection, make sure you escape all the output. Always use HTTPS for everything, static resources, non-static resources, whatever. I don't submit sensitive data is not an excuse. Use HTTPS because otherwise bad things happen. Consider having cross-site request forgery protection. It's not always mandatory, because in some cases you're not vulnerable to that, but have it in mind. Minimize external static resources. It's easy to include some static resources. It's easy to not put them on your infrastructure, but that's tricky and that's risky, and you should minimize that. And regularly scan them. You should know when they have newly discovered vulnerabilities. Disable framing. This is a specific header that you should set to your website so that nobody can actually frame it in an iframe, or because this is how they can exploit it. Regularly update your dependencies. Get notified on new vulnerabilities that get discovered, because that happens regularly. Fortunately, GitHub has that functionality. It automatically notifies you when there are vulnerable dependencies, and many, many more. Now, a little bit about backend vulnerabilities. The most horrid one is the remote code execution. If that happens, it's most often game over, because someone was allowed to execute code on your server. Now, if they don't have the right privilege, it might not yet be game over, but still it's very, very bad. As I said, that GitHub notifies you about things, about vulnerabilities. Recently, I got a notification that a famous Java JSON library, Jackson, up to a very recent version, allowed remote code execution by just deserializing carefully crafted JSON. And that's scary. So an attacker could just send you some JSON and be root and execute stuff on your Linux machine, and that's horrible. So yeah, do regularly scan your dependencies. Your code itself may introduce such remote code executions, as we'll see in the next example. So if someone uploads a file, don't run it. Sounds obvious, but not so. And yeah, check if your dependencies don't accidentally expose such vulnerabilities. SQL injections, kind of a trivial thing to grasp. Still, it happens too often. It practically gives an attacker access to your database. They can get all the data, or they can destroy your data. They can do anything. And this is basically by allowing, by having your queries concatenated with the user input. So if the user input from the get parameter is the user ID, and you don't do anything with it, don't sanitize it, you don't use prepared statements, then an attacker can type a specially crafted value, which is 1 semicolon drop table users, and then your query would look like that. And it would obviously first select things and then drop the table. Some databases with some sophisticated functionalities can allow them to even get all the data and send it to an email or send it to an external API. They can basically screw you. Use prepared statements. That is the default option for that. Weak authentication is another major backend problem. That includes a lot of things like bad password storage, for example, using MD5 to store passwords, non-secure session cookies. Your session cookies should be marked as secure because you are using HTTPS, as we said already. And if your authentication is bad or you don't have one, as by the way, in the example earlier today, someone showed a Jeep that attackers could crash while not in the car. Well, one of the issues there was that they were having unauthenticated endpoints in the car, and you could connect to them externally, and that was horrible. Prevention, it's not tricky, it's not easy. You should review your authentication security regularly. You should use bcrypt or similar to store passwords. Just having MD5 or even SHA is not enough. And you should prevent attempts to brute force authentication. Some funny stories. There was a popular blog post recently, how I hacked 40 websites. And it was about a remote code execution attack. Basically, the guy uploaded a PHP file instead of an image. It was supposed to be upload your profile picture, but he uploaded a PHP file. And turns out that the website didn't do any sanitization on that and allowed him to run it by URL. So the image was supposed to be uploaded somewhere, and you could get it by URL. Well, he invoked the PHP file, and then he got access to the whole machine, because through that PHP file, he basically created a shell for himself. And why it's 40 sites? Because the vulnerable site was one, but it was a shared hosting. So there were 39 other sites on that machine that he could also manipulate. The fix sounds easy. Check your upload contents. Don't allow people to execute them. Fortunately, languages like Java, you cannot just upload the Java file because you have to compile it and put it in the runtime. But scripting languages like PHP allow these kinds of things. One story: when I was advisor in the Council of Ministers, some investigative journalists discovered that personal data for ministers, for diplomats, for directors in the administration were leaked or could be leaked from a government website. And so I asked the investigative journalists what's the problem. Turns out to be a simple SQL injection on a website that was used for something like tourism or reservations or whatever within the administration. Turns out it wasn't supported for years because the company had gone bankrupt. But fixing that was just a matter of a few lines of code that I added to the site while I literally went down the basement in the Council of Ministers and fixed it. So use prepared statements, then SQL injections can't happen and people can't leak your data. If you can't use prepared statements because of an older version of PHP, which was the case, try to escape or sanitize your input as much as possible. Another thing was the recent Marriott data breach. It's a huge hotel chain. They actually bought other hotel chains, which was the source of the exploit. and attackers got millions of passports and visitor locations. So not only your passport number, which is not that interesting probably, but also where you went in the past 10 years. And that was useful information for example, Chinese intelligence, because once they knew from previous breaches who were the people with high security clearance in the US, then they could match them to the Marriott things and see where basically US agents were around the world, which is kind of scary. What was the problem there? Well, they stored all of that data unencrypted, and it could be just extracted by using select star. How to prevent it? The general cybersecurity practices and IPS is intrusion prevention system, so do have some way to detect, at least, if not prevent intrusions, but also encrypt your sensitive data at least in a more granular way, so not just encrypt the whole database at rest, because that protects you from something grabbing the hard drive, but doesn't protect you from someone doing select star. So granularly encrypt sensitive data at least. And some best practices here again. Use prepare statements. I've said it too many times now. Force use HTTPS. This is also repeated here. Simply having an option to use HTTPS is not enough. You should redirect HTTP to HTTPS always, without any exceptions. Validate the input on all layers. It's not enough, obviously, to have it validated just on the client side, because people will circumvent that. But also on your other layers in the backend, do some validation there as well, because at some point you may introduce a RESTful API in addition to your user front-end way of gathering data, and then the validation might either have to be duplicated in the RESTful layer, or you can forget it. Regularly assess your protocols. If you have some custom ways of exchanging data, some tokens, password reset flows, whatever, check them regularly to see if they are up to the scrutiny of the current requirements. Because yesterday there was an article about the two-factor authentication flow of Google and Instagram and Facebook and many others, and turned out that they have an issue there. It was too complicated to explain. Now it's an edge case, but still, even the best companies have issues with their two-factor authentication flows. Again, check dependencies for vulnerabilities, encrypt as much as possible. Encryption is not that expensive in terms of resources. Encrypt sensitive data granularly. So, for example, if you have to store passports, encrypt them per record if possible. This is actually what we do with one of our products, the Sentinel DB one. We allow encryption per record, not just a broad encryption. Use bcrypt for passwords, or scrypt or similar. Regularly review your authentication mechanisms, whether it's API authentication, OAuth. OAuth has a number of vulnerabilities. Don't invent cryptography. It's hard. It's tested and verified in very formal processes by scientists, and simply inventing your hashing algorithm or your encryption doesn't work. Don't do it. Log cleverly means log as much as possible, but not more. Because if you log personal data, as we'll see in one example on the next slide, if you log personal data or credit card numbers, that's bad. So log as much as possible to be able to navigate what happened, but don't log too much. And keep an audit trail. Audit trail is usually equated with logs, but it's not exactly. The audit trail is what happened from a business perspective. Who clicked where, why, which screen, what transaction was performed, and keep that audit trail protected. It's not simply a log file. It should be guarded at least with digital signatures. Now, our other product is making sure that this audit trail is not modified by any way, but at least do some basic cryptography on it, like signing it or timestamping it, to avoid someone from changing it and you don't notice. We've got to the infrastructure vulnerabilities, and there are all sorts of them. Your credentials the credentials of administrators can leak, and that makes it practically the same as insider attack, because if they want to attack the system, they already have the credentials. It allows basically full control over your system, including if you have to protect all kinds of credentials, not simply the SSH certificate that you use to log into the machines or your AWS credentials when you use AWS, but also your DNS management password. And we'll see in a bit why. How to prevent that? Use multi-factor authentication. It's quite easy. For your infrastructure, use, and when I say multi-factor authentication, I don't mean just in some web management console. Use it also in SSH. You can very easily set up Google Authenticator in order to allow SSH into a machine, and that's a good practice. Whitelist IPs that you connect from. Don't just allow, even if you have a Bastion host or some other machine that kind of is in the middle between your infrastructure and the internet, do restrict the IPs from which you can log in to the office, and do have audit trail. Other issues come from misconfiguration, older security suites. As I said previously, if you allow downgrade attacks to SSL version 3, then someone can do a man in the middle. And other sorts of misconfiguration like exposed directory structures, just not configured security at all, and other issues. How to prevent that? Well, not an easy way. You should have to do regular penetration tests, regular reviews. It's more of organizational measures than technical ones. And the unpatched software issue rises here again. It increases the risks of 0 days, whether it's from the operating system, whether it's from some important libraries like OpenSSL. The good thing again here is to kind of get notified about CVE vulnerabilities. This is the database for vulnerabilities. You can set that to automatically get notified, even if you're not using GitHub. The examples here, Heartbleed was a famous 0-day vulnerability with OpenSSL, which practically meant that it's as if you don't use HTTPS. It's as if it's plain text. Well, not exactly. It's harder than that, but it could expose any connection. How to prevent suffering from 0 days? Well, you can't, because this is why they're called 0 days. But you can have a pretty fast, if not automated, way to patch that. What we had when I was working at TomTom back then when Heartbleed hit, and the team had designed a protocol. It took them a month. That is some encryption on top of SSL. And it looked kind of useless because, well, you already have the communication encryption. Why do another layer of that? Well, we were quite happy when Heartbleed hit because we were not vulnerable to it, even at day 0. But that's kind of an edge case. When I said DNS previously, there was a recent hack on a Brazilian bank because nobody touched their infrastructure. Nobody could penetrate their core banking system, their servers, whatever. But they managed to steal the DNS management panel password. And so they pointed all of their domains to other websites that were malicious, and they collected some data from there. It's that trivial. So attacking the weak spot means that if even one of your passwords is not properly protected, and you don't have two-factor authentication for the DNS management of a bank, then you're vulnerable. Recently, this is a personal thing. I was checking in for a flight, and the system, after the successful check-in, forwarded me to a directory structure. You see all the files in a particular directory. And that's obviously a misconfigured server, where they have just not disabled the directory listings. However, at first, it seemed that there are only static files there, JavaScript, CSS, whatever, not interesting things. But when I dig deeper, turned out that they're storing their current access logs on that server, and they're accessible through the directory structure. In those access logs, they had all of the requests, obviously, but the parameters, the itinerary numbers and the person numbers and the flights, were get parameters. So they were visible in the URL. So practically, you had access to whoever has checked in for whichever flight, and you could get all of that data, who traveled where. I reported it. They fixed it 3 days later, so probably no damage done. But still, a simple misconfiguration could leak the travel patterns of millions of people. Reminding me to, again, say, do not log any sensitive data, do not put sensitive data in get parameters, etc., etc. Use multi-factor authentication as much as possible. Configure network security rules. We saw in the previous presentation how this can and should be done in Kubernetes. There are other ways for software-defined infrastructure. Monitor your traffic. This is more of an ops thing than a development thing. Keep software up to date. I'll probably say it 1 or 2 more times. Do penetration testing. Protect your logs, because just simply having the logs doesn't mean someone hasn't modified them and you haven't seen who has modified the logs. Encrypt secrets, because an application usually relies on secrets, some sort of secret. An API key for this service, an API key for that service, a password for this and password for that. These should be encrypted on the file system, and then the application should have some way to decrypt them. It is a bit security through obscurity in the end, because if the application needs it, then the server should be able to get them. But adding one such hoop makes it harder for an attacker to just go into the system, fetch all the files, and have everything. There are these systems called privileged access management. Take a look at them. They're very good for larger infrastructures. Don't store production credentials in code repositories. Quite an obvious thing. Still, if you go to GitHub and Google password in .properties files, you'll find millions of repos probably that have done the mistake of storing that, including, unfortunately, some government projects. Disable all these old cipher suites. They are vulnerable. You probably don't need people using Internet Explorer 6, so just disable them. And use CMs for anomaly detection. These are systems that you deploy, and they monitor allegedly everything and notify you if something is happening incorrectly. And finally, we've come to the human factor vulnerabilities, and they are the hardest to prevent with technical means because they are, as I said, human. The spear phishing is one of the issues. It is a targeted fake email, and it could lead to practically controlling the whole infrastructure again. Well, not always, but if you send a phishing email to the administrator to log into his DNS account in order to confirm his whois data, for example, and he does that, and then you have their DNS record, and then you change them, and then you have 80 domains of a Brazilian bank. How to prevent those things? Well, at least multi-factor authentication can help here, but not always, because phishing sites can go around multi-factor authentication by just acting as a proxy. And when the original site requests the token, the phishing site also requests the token, and you type it in. You should scan emails, have audit trail at least to know what has happened when the problem happens, as we'll see with the DNC, and general good security practices. Social engineering in general is a problem. Because if people use some personal details for their security questions or whatever, or passwords, knowing where they lived or what's the mother's maiden name or the name of their pet could actually compromise security. So yeah, do not use personal details for passwords or for security questions. And the lack of training is the general problem here. Staff should be trained to kind of see social engineering and spear phishing and other human factor vulnerabilities. The examples here, the DNC hack, quite infamous. It happened by sending a spear phishing email pretending to be Google. So here, reset your password. And then they obtained John Podesta's password and got access to his emails. That's as simple as that. I mean, the whole scandal in the US with the Hillary Clinton emails that probably swung the election was a phishing email. And these things sound trivial, but they have dire consequences when not treated properly. He was a non-security employee, he was a non-technical employee, and they should be trained as well, because they happen to also have access to some interesting information. There could also be filters that auto-detect phishing, that check the links, see if they pretend to be someone else that they're not. Some tools help you with that. Obviously, if there are such tools, use them. Another example, very similar, RSA, where RSA Secure ID is allegedly a secure way to to do two-factor authentication, among other things. But again, the way it was built, the blueprints for the secure ID were obtained by an attacker by, again, spear phishing some stuff that was not involved with the particular project, but allowed the attackers to execute a flash zero-day exploit on their machine, and then from there go to the network and do some other things. So this is, again, non-technical employees were attacked, and this is scary. Yahoo breach, similarly things, non-privileged employees, not system admins who would probably notice what is happening. They were sent emails, they clicked, they gave access, and then it was game over. One of my favorite comic strips, in the movies, people kind of present hacking as someone doing very sophisticated, complicated, hackery things. In practice, it is that, obviously, but also there is, hi, I'm Robert the Hacker Man, the county password inspector, can you give me your password? And people do, because they're not trained to detect those kinds of things. How to protect the human, and that's hard. All the other best practices in the previous slides combined, plus regular training, but not just of the technical employees who probably already know how to prevent these things, of everyone. Background checks for security systems, for highly security systems, because people might be vulnerable based on their background. They might be extorted, they might be other issues with their background, so do that if you're doing with government secrets or whatever. Do have audit trail, so that at least when something happens, you know what has happened and you can prevent it the next time. Use multi-factor authentication. Do have a policy for mobile device security. It shouldn't be just someone bringing their own phone, connecting it to the network, and doing whatever they like. There should be regular social engineering drills, so someone doing penetration tests should pretend to do spear phishing, for example, to some employees and see how they react. If they don't detect it, then they should be trained again and again. Scan the emails, try to detect phishing automatically. These are probably some systems that the operations department should install, but something to have in mind. And access to critical systems by system administrators might be done via split key. So no single person should be able to log in the server for a particular very critical sensitive system. There should be two of them using a split key to be able to identify there. So is that it? Is it the whole security thing condensed into a few slides? Obviously no. Obviously nobody can give you the whole complex picture of information security in 30 minutes. And this is a problem. Some people may say, well, we are certified. We're certified with ISO 27000, PCI DSS. We are certified security professionals and whatnot. And this is a good start. This is a good start because these standards have many of these good practices. They have many of these recommendations of how to do things, how to encrypt data, how to use multi-factor authentication, how to do the regular trainings, etc., etc. But this is not enough. It says what to do. It doesn't always verify that you have done it properly. All it's happened to omit many issues, and we've seen that. And probably all of these breached organizations, Marriott, British Airways, they did have all these standards, and obviously they did rookie mistakes, basically. So it's a good start, but not enough. The way I think this should be addressed is through all of the talks from this afternoon about security coding practices, but also just a general security mindset of the engineers, of the operations people, of everyone. Whenever developing new functionality, whenever deploying a new service, whenever commissioning a new server, always ask what can go wrong. This is a simple way to say define your threat model, but at least even if you don't do it so formally, try to ask what can go wrong. Try to stay up to date, both in terms of knowing what are the current trends in attacks and in vulnerabilities, and also having your software up to date, obviously. Strive for simplicity. Now, this doesn't seem related, but simple software is obviously less vulnerable because it has less of an attack surface. So strive for simplicity because very complicated things happen to have issues where you don't expect them. And maybe most importantly, don't assume that someone else has taken care of security. oh, we're developers, the operations people will configure the file load and the intrusion prevention system, and it will be fine. Well, yeah, but that might not catch the CQRS issue or a SQL injection or whatever. So always be conscious of security regardless of what your role is. Can tools solve these problems? Well, partially. As I said, we're in the business of building such tools, but even if that goes against my business interest, I'd say that they solve half the problem. People have to solve the other one. At least you have to be able to install and configure these tools. And knowing your tools is hard. Introducing more tools introduces more complexity, and sometimes they can be additional source of vulnerabilities. And look for the best tools, but don't be over-reliant on them. Don't assume that your firewall will just save you when the issue strikes. And have a plan. Things will go wrong. But your plan should not be just running around in circles. You should be prepared to react. It might not be a document based on an ISO standard that says what do we do in case of a breach, but have it in the back of your mind, have it written somewhere in Confluence, in Jira, or wherever. Just if something bad happens, what do? We gather, we convene, we discuss for 20 minutes, and then we react. For small companies, that would be enough. So what I've been saying in the past half hour was don't do that, don't do this. Well, do this and this, but don't forget to do this big list of things. Don't assume you're secure. Don't be complacent. Don't be reliant on that tool. Don't be this and don't be that. And this is why my talk was titled How to Create Secure Software, because you don't have to blink. If you blink, the enemy is there. And this is a reference to a favorite Doctor Who episode where the alien was able to attack only if nobody was looking at it. Even if you blink for a second, it was very quickly approaching and trying to attack you. So unfortunately, there's no easy answer to security. You just have to be very, very careful and not to blink. Thank you.
Thank you very much for these fantastic presentations. We have time for a couple of questions. So if there's someone else who is willing to ask. Thank you.
Hello, my name is Ilyan Majarov. One of the last slides was saying that you should be ready to react. I am just curious, do you know of a company or a person which is trying to be proactive, trying to invest time to actually find new exploits? Because obviously from time to time there are some new things that we haven't seen previously. Do you know of such a company or person that tries to exploit something new?
Yeah, well, TomTom, where I used to work, we did this regular penetration test that we just hired an external company, I said, try to break in. And this is one thing that I recommend doing if you're a big company.
Hi, Martin Rusko.
Other questions?
This gentleman over here.
Yeah, so you were, okay, let me make it into a provocative part and a bit more. So you said don't blink. Is that reasonable to try to do?
No.
This is the provocative part. And then the more realistic part. I mean, you were talking about, non-technical users are very easy to be spearfish and so on. I don't think technical users are any safer than that. So I think it's, yeah, basically the risks are much bigger than we can solve directly. So I mean, earlier today, people were saying, and I'm sorry, I don't remember who it was. Actually, you have to assume that you're already being attacked and that you already have
yeah, absolutely. You have to assume that you're under attack 100% of the time and not blink. And also, yeah, your technical staff may be more prepared to fight these attacks, but the risk there is higher because they have the proper credentials to access the backend system. So treat them as if they don't know what phishing is.
So, no any other questions? Let's say thank you very much. Bozhidar, it was a great presentation. Thank you.
Thank you.